To begin with our first session of the day, we have a very special keynote by Dr. Masahisa Kawashima, who is currently leading NTT Corporation's R&D on innovative optical and wireless network ION. He is thus serving as the ION Technology Director and also as the chair of the Technology Working Group at the ION Global Forum. Masahisa has been working as a bridge between technologies and businesses since joining NTT in 1994, so 30 years now, and specializes in high-speed networking, SDN, cloud edge computing, AI, and data management. Nowadays, he is exploring innovative ways of making products, services cloud native, leveraging the evolution of optical communications and optoelectronics integration technologies. Today, his talk is on how we can achieve economic growth and global sustainability with optical transport evolution. Please help me welcome Dr. Masahisa Kawashima.
Thank you very much for having me. I feel very honored to make a presentation at such a successful council of IX experts. Today, I'd like to talk about the future of data centers and peering with the title, How We Can Achieve Economic Growth and Global Sustainability with Optical Transport Evolution. So let me start with my self-presentation, but the MC has already given a nice introduction. Basically, I'm a system and infrastructure architect with expertise in network and IT, and I have long been working as a bridge between businesses and technologies. And I'm a kind of strategy thinker, and these are my past achievements. So this is today's outline. I'll start with describing a program so-called Data Center Moratorium. After that, I point to today's network limitations that lie behind this issue. And after that, I propose a solution with ION, an innovative optical and wireless network, which is a concept to re-architect network and compute infrastructure with the evolution of optical communication device. And as ION is not NTT's single company effort, I will introduce a global collaboration at ION Global Forum. Then I'll conclude my talk. So let me start with data center moratorium issue. So as you know, we need data centers to operate computers. And data centers are getting bigger and bigger. And today's typical big data centers consume about 120 megawatt, which equals the energy consumption of 250,000 households. So one big data center is like one big city in terms of energy consumption. AI has now become essential in many industries, and this will further increase data centers' power consumption. According to a report published by University of Massachusetts in 2019, one transformer training emits CO2 as much as about 57 humans' annual carbon emission. Can NVIDIA's effort reduce this carbon emission? The answer is no, because while the computing efficiency has been increasing 3 to 6 times every 2 years, the AI workload, the number of computations, has been increasing about 30 times every 2 years. So that the gap will keep widening. And as this is an IX experts council, so most of you are familiar with this situation. To make matters worse, such data centers are concentrated in urban cities. As you see in this slide, New York, Frankfurt, London, Tokyo have many data centers in their downtown areas. This map shows the energy demand by region In the red area, the energy demand largely exceeds the renewable energy supply. And in the blue area, we can expect the surplus of renewable energy supply. And in the green area, the renewable energy balances the energy demand. Of course, in urban downtown, the energy demand largely exceeds the renewable energy supply. So data centers in urban downtown make the situation worse. In other words, urban data centers would increase the society's CO2 emission. That's why some cities such as Amsterdam, Ireland, Groton, and Singapore have started holding off the construction of new data centers. This move is called data center moratorium. So we cannot survive and thrive without solving this problem. So why data centers are getting larger and concentrated? This is related to today's limitation of networks. So let me start with reviewing today's network structure. So this slide shows today's wide area network. User sites, which you see in the left side, maybe data centers or campuses, are connected to IP1s, packet switching networks. On the other hand, cloud service providers do not use IP1 services to connect their data centers. Instead, they deploy fiber cables to interconnect their server sites, so-called server farm DCs, in one local area called availability zone. And to connect such availability zones and for carriers to connect to create a region-wide network, they build ROADM networks. And finally, and most importantly for us, network service providers and cloud providers are interconnected at a rendezvous point called connectivity DCs, and we need IX as a hub function. So this is the overall structure of today's one. To understand the data center's concentration issue, it is important to note that communication space and computing space are different. Today, we have internet. It is a great network that connects us all over the world into one space. But that space is a communication space, which is mainly for human to human or human to server, human to computer communication. For communication, what we need at minimum is best effort packet reachability. We can tolerate packet loss and tens of millisecond latency. On the other hand, in computing space, where computers interact to do some task or share some resources, the requirements on the network service quality are much stricter. In particular, the latency requirements are very strict. I will explain why the latency is important for computing space using cloud-native database as an example use case. As most application systems use databases at their core, a computing space should desirably support the deployment of high availability database. As you see in this figure, cloud databases achieve high availability by writing write-ahead logs to multiple storage devices on different data centers. With today's NVMe storage, the disk write latency is just about 50 microseconds. It's less than 50 microseconds. So the database performance is largely affected by the message latency. And practically, for synchronous database replication, the message latency should be less than 500 microseconds. And database is just one example. Many other computer-to-computer interactions have strict latency requirements, as you see in this slide. For LAN storage sharing, it should achieve a few hundred microsec message latency. And for database synchronous replication, again, it should be, the message latency should be about a few to several hundred microsec. And cloud service, what? Can I? Okay. For cloud service microservice applications, the message latency between microservices should be about a few to several microsec. And it is important to note that this is about the message latency. It's not the packet latency. When we transfer message over TCP/IP, basically the message latency is a few times larger than the packet latency. So given such strict latency requirements, can distributed data centers form one computing space with today's technologies? So for example, can we use IP1 to connect data centers distributed widely into one computing space? And one of the issues is with IP1, we cannot be free from probabilistic packet loss. So basically, we have to assume that the message is transferred over TCP/IP, and the message latency would be a few times larger than the packet latency. So because of that, it is very hard to connect computing data centers into one computing space with IP1. So we have RODAM. So can we distribute RODAM nodes to many points so that we can connect data centers distributed widely? And the issue is RODAM is very high capex system. So if we were to distribute RODAM to many points, the connectivity cost would be too high. Now we have dark fiber. So this could be the solution, but if we were to use dark fibers to connect distributed data centers, basically it may be possible in some areas, but one of the issues is the lack of agility. It usually takes months to find available fibers. And also, basically, it depends on areas. In some areas, we cannot find remaining fibers, and it would be inefficient fiber utilization. So basically, we would soon run out of fibers. So, in conclusion, because each network has a limitation, we cannot distribute data centers in a wide area with today's network technology. So now I'd like to talk about our proposal about solution, ION, Innovative Optical Wireless Network. So this is one slide summary of ION. ION stands for Innovative Optical and Wireless Network. So basically, it's an initiative to re-architect network and compute infrastructure with optical device evolution. And important point is we promote architectural innovation as well as device evolution. This is the key point. Just developing an optical device is not good enough. We have to re-architect the whole infrastructure to make the infrastructure more efficient. So I'd like to talk about the fundamental technology, APN, All Photonics Network. So what you see in the left side is today's RODAM. Although today's ROADM is a high capex system. It has now become a composable system to address a variety of user demands. But basically, this is an integrated system. So the whole system should be provided by a single provider and should be placed to some places, a single point, and should be owned by a single operator. So what we did as ION APN is to disaggregate this ROADM system into multiple components and define open intercomponent interfaces so that we can distribute components to multiple points. And so with this, you see on the right APN-I and APN-G and APN-T. So APN-T is basically a transponder. So the main part of APN-T is transceiver. And APN-G is basically a max and demax node. So the main function of APN-G is multiplex and demultiplex. And it forwards the multiplexed optical signal to the upper node called APN-I. APN-I is basically an exchange node. So it takes DWDM signals from multiple directions and performs exchange among the ports. It's like leaf spine architecture of packet network. We have spine, leaf, and top of rack. Like that, we have IGT. And this is defined by ION Global Forum. Because with this disaggregated architecture, we can achieve wide area coverage. So today, because ROADM is a high capex system, ROADM can be deployed to a small number of places. So area where we can connect sites directly to the ROADM infrastructure is limited. On the other hand, with APN, components such as G and T are not so expensive as traditional ROADM. So we can distribute G and T to many places. So with this mechanism, we can achieve wide area coverage. But if one carrier had to invest into all G and T nodes by itself to achieve wide area coverage, that would be a huge investment risk for that carrier. So, but APN's open interfaces for component separation will help us solve this issue. With open interfaces, we can have several service providers such as IX, VPN, and DC providers on G or T nodes and resell carriers' optical bandwidth. This is similar to food chain's franchise business model. We can have place owners to take investment risk and share profit. This is a business innovation brought by OpenAPN. So this is an overview of evolved WAN with ION APN. As you see in this slide, we do not intend to replace IP network with APN. Instead, we intend to complement today's IP networks by adding high bandwidth, low latency data planes to today's network. This is like today's today's car transportation. We have surface streets and highways. So if you'd like to go to a distant place then you would take highway. So like that, likewise, we can have IP network and APN. So if you need high bandwidth, low latency connection, you would use ION APN. So this is the evolution we propose. So how data centers How would data centers change with ion APN? So as you see in this slide, today's data centers depend on physical interconnect with cable construction. So with this interconnect, it takes a long lead time and a large fixed cost. So basically, the data center interconnection is data center provider oriented. And so, once you deploy fiber cable, you don't have to be worried about the bandwidth. The bandwidth is almost free between these interconnected cables. On the other hand, this is because the cable construction takes a huge investment. Basically, this is effective only for the large data centers. So what you see in the right side is ion APN-based data center interconnect. Basically, it can be on demand because carriers provide wavelength paths, and data center providers can connect data centers with such wavelength paths. So the data center interconnection can be on demand. So instead of being data center provider oriented, data center interconnection can be data center user oriented. And basically, data center can form internet of data centers with ion NPN. So it can create a data center group based on users' demand. And also, bandwidth granularity is important. One wavelength path is about 100 or 400 gigabits per sec. So we can create a data center interconnection with such fine granularity. So NTT has already conducted proof of concept. Of course, we have started operating APN in Japan, and outside of Japan, we have already done POC, and now having internal discussion as to how to roll out how to roll out APN-based business. So we have done a POC in US, North Virginia area, and also in UK, in London area. And we have confirmed that this concept is very effective, not only in Japan, but also in other parts of the data center cities. And APN will help you distribute data centers. Today, I think this is not the only case in Japan, but also in other nations. Now, urban areas are full of data centers. So now you are now constructing a hyperscale data centers in suburban areas. But once you find some suburban area and start constructing hyperscale data centers, that area will soon be full of hyperscale data centers. So that's today's situation. So even if you create, even if you find a suburban area, that area would soon be in trouble with CO2 emission. That's today's situation. So what ion APN can do is to distribute data centers widely so that each data center can be operated with locally renewable energy. So with this, we can help societies achieve carbon neutrality while investing into many IT technologies for society's economic growth. And also, with ion APN, we can allow customers make use of their own sites, such as customers' campuses or customers' data centers. Today, we often discuss hybrid cloud. That means connecting customers' private cloud with public cloud. But what happens today is typically customers have deploy some IT systems for private clouds and some other IT systems for public cloud. But they don't have private clouds and public clouds share a computing resource pool. So with this usage, basically the IT systems in private cloud are often tended to be underutilized in terms of IT resources. So that's why now many people are talking about cloud first. That means abandon your private DC and start using public cloud mainly. So this is today's situation. But what Ion APN allow is we can allow customers to make use of customers' campuses and data centers, because with Ion APN, we can create one computing space with customers' private sites and public clouds. Forming one computing space means allowing sites to share one computing resource pool so that the IT resource underutilization issue would not be a problem. And this would be a good business model for real estate developers. So because today, real estate developers construct many new buildings, and they want to raise the value of such buildings by introducing new IT systems. But in order to do that, of course, they need to deploy computers, but they don't want to use their spaces just to deploy computers. This is the problem with urban development. On the other hand, typically data center, real estate developers also invest into data center areas, data center, the lands for data centers. So, and typically they invest in the land in suburban areas to construct data centers. And they are trying to find a way to raise the value of suburban data centers. So what we can do is to connect real estate developers' urban estates with suburban data centers. Then urban estates can be enhanced with smart IT systems while using computing spaces in suburban data centers. So with that, the estate developers can raise the value of real estate in urban areas. And this means, from the viewpoint of suburban data center business, they can raise the value of suburban data centers because they are connected to, suburban data centers are connected to urban buildings where many people gather. So with this complementary relationship, we can, the real estate developers can raise the value of their assets. So this will motivate real estate developers. So this is one of the business model to make people adopt APN. And this is an example of technical experiment for such a business concept. So suppose we have urban buildings and we would like to deploy AI-based surveillance. And instead of deploying AI computers in urban places, we can have suburban data centers provide spaces for such AI computers. And by connecting the urban buildings with suburban data centers with Ion APN, we can reduce the number or the total amount of power consumption. And at the same time, we can reduce the CO2 emission of urban areas. And so how would peering and IX would change with ion APN? So what you see in the left side is today's peering. Basically, today's peering relies on place. Basically, the basic concept is everybody gather at a rendezvous point and interconnect their routers with fiber cross connect. So that is today's IX. And each provider has a regional network, and most of providers construct regional networks with IP1. So basically, what we can do is, what we can form is a communication space, but not good for computing space. What we can do with ion APN is, first of all, we can make peering not rely on a single rendezvous point. Rather, we can realize network-based location-free peering. That means you have IX service providers can have their own POPs to distributed database, distributed networks, and they can connect such distributed POPs with ion APN. Of course, I think you have already do this kind of approach, I mean, placing many POPs to different data centers. But what I mean is, by combining ion APN with IX, you can distribute IX to many more DCs. That is one advancement. And the second advancement, as you see in this figure, IX providers can provide IX for communication and IX for computing. As you see, if you provide a wavelength port to your service providers, then the service providers can create a wavelength path, so that the two service providers' computing space can be jointed. So this is another value that we can add with ion APN. So this is, again, the bandwidth supply chain with ion APN. So IX and VPN providers or data center providers can start a new business with ion APN's value chain. So obviously, accomplishing this requires a global community effort. So we established ION Global Forum. It's an open global community. So ION Global Forum is an open global community for the next generation communication and computing infrastructure that leverage the evolution of optical communication and photonics electronics convergence technologies. It was established in 2020, and ION stands for Innovative Optical and Wireless Network. And this is a list of board of directors. We have NTT, Intel, and Sony are the founding companies. And what you see in the bottom are elected board of directors. We have Sienna, Ericsson, Orange, Microsoft, Chunghwa Telecom, and Nokia, Fujitsu, KDDI, and Accenture, and Red Hat. So as you see in this list, we have leaderships from IT and network and user experience and consulting companies, and we have leaderships from Asia, Europe, and US, North America. And this is a list of membership. Currently, the number of memberships is 142, and we have most of influential network and IT equipment companies and influential service providers. For example, when it comes to cloud service providers, we have Microsoft, Google, Oracle, and we have Google, Microsoft, Oracle, yes, and except for AWS. We have a long discussion with AWS. AWS shows strong interest in ION Global Forum, but they haven't yet joined it. So why we need ION Global Forum? For optical communication, we have OIF, Open ROADM already. Why we need ION Global Forum? Because we need infrastructure level evolution. Even if we have OIF and Open ROADM, without ION Global Forum, basically the infrastructure evolution is just an upgrade and today's all IP architecture. But as you see in today's presentation, it is important to re-architect the whole infrastructure architecture. So that's why we have started ION Global Forum, but we leverage the output of OIF and Open ROADM because in terms of component specification, their specifications are very good. So basically, we respect their specification. So, and we often do, now we are making a good relationship with Open ROADM and OIF. And also for transponder, we are making a good relationship with TIP. So this is ION Global Forum's activity. So today I talked about APN, which is a network layer, but just upgrading network is not good enough. For example, as I said, we have to replace TCP/IP-based data transfer to reduce the message latency. For example, we can introduce RDMA and some kind of accelerated data transfer technologies, making use of ION APN's network quality feature. So on top of ION APN, we define that network architecture to provide guaranteed bandwidth, bounded latency, packet flow. That is called ION networking service. And on top of that, we define computing architecture that performs short latency message transfer, leveraging ION's network quality. And on top of that, we define how we create a database and storage with a work item titled data space. And also we define how mobile network operators should make use of ION infrastructure to deploy a 5G and 6G radio access network. That is called ION for mobile networks. And also fiber sensing is another work item because optical network can be used not only for data transport, but also for sensing. So in fiber sensing work item, we define how we can add a fiber sensing probe to ION APN's infrastructure to use optical infrastructure as a sensor. And on top of that, we define use cases. So this slide shows early adoption use cases. So we know being innovative means being too risky. The majority of customers do not want to be the first penguin to adopt new technologies. So we need to show a business model to motivate customers accept innovation technology risks. So we define early adoption use cases. And in these early adoption use cases, we clarify customers' benefits. of using ION APN and plan POC activities so that customers can recognize their advantages from the live implemented system. So for such activities, now we run 4 items. One is financial service infrastructure. The second one is remote video production. And the third one is AI factory. And the fourth one is 5G, 6G mobile network. So for example, in financial service infrastructure use case, financial service institutes can build multi-DC DR-enabled databases with ION APN. And this would help financial service institutes reduce the CapEx and OpEx of their service infrastructure. And in remote video production, TV broadcasters can use ION APN to have their production staff remotely control the video stream, remotely edit the video streams. Today, they have to send video editing professional to the streaming sites such as sports stadiums or musical concert places. But with ION APN, TV broadcasters can have the video editing professionals remotely do the editing over the ION APN. The third use case is AI factory. So today, AI has now become very important in many industries. For example, of course, car companies need to develop autonomous driving software, and chemical industries need to use AI computers to find a new combination of materials. So AI now has become the center of competition, and they have to use a large AI computer cluster, but having such AI computer clusters by themselves is very risky, because the life cycle of AI computer is very short. So they want to share AI computers on the cloud. But basically, for industrial use cases, industry customers do not want to export their data to the cloud because the data is their asset. So what we can do with ION APN is to allow customers to maintain their important data in customers' places and use AI computers on the cloud where they want to analyze their data. What we can do is to use ION APN to transfer customers' data to GPUs with small latency. So with that mechanism, customers do not have to place copies of their data to the cloud, and this would help them utilize GPU computers on the cloud for their AI production. And the last use case is mobile networks. Now everybody is talking about 6G, but one of the issues with 5G and 6G is because we use high frequency bands, it is important. One of the important factors is agility of antenna deployment. Because we use high frequency bands, it is subject to the line of sight. So we have to deploy antennas on an area where needed. And such deployment agility is needed. But if we use dark fibers to deploy antennas, the mobile operators cannot achieve such agility. So what we propose is use ION APN to make antenna deployment more agile. And this would also help mobile network operators share the TCO of radio access network. And this is another important aspect of ION Global Forum's activity. We believe that just producing document is not good enough to get our technology concept implemented. We value that our technology, what we define should be proven by our implementation activities. So what we do is we encourage members to conduct technical experiments like POC and benchmarking and report back to ION Global Forum community so that we can update our technology definition. So with this mechanism, we can develop truly viable and practically operable technologies. And also, in addition, ION Global Forum runs an activity called energy efficiency program, which evaluates ION Global Forum's activities and gives some guidance so that the forum's activity addresses the environmental concerns very efficiently. So if you are interested in ION Global Forum's activity, these are the SNS feeds. So please look into these sites. So I think I'll conclude my talk. I think I can have 10 minutes or so. So if you have some question, please do not hesitate to raise your question or comment. I sincerely appreciate your feedback. So I talked about data center moratorium. And next, I point to today's network limitations, and this is one of the reasons why we cannot support wide data center distribution. And then I introduced infrastructure evolution with ION. One of the important concepts is APN, or photonic network. APN disaggregates today's ROADM into multiple components with open interfaces, and this helps us build a bandwidth supply chain with multiple providers in the chain. And I propose evolved one with ION APN. So ION APN will complement today's IP network by adding high bandwidth, low latency data plane. It's like adding highway to surface streets in car transportation systems. And the future of data centers will be software-defined and user-oriented interconnect-based data centers. And future of peering. Today, basically, peering is a place-based peering, but with ION APN, peering will be network-based, location-free, and IX providers can play a hub function for communication and also for computing. And this is not NTT's single company's effort. It's a global effort supported by many IT and network companies in the world. So if you are interested in this activity, please join ION Global Forum. So that concludes my talk. Thank you very much for your attention.
Thank you very much, Dr. Masahisa, for your highly technical and insightful talk. I would like to open the floor to questions. Just raise your hand and I'll go over to you with the microphone.
Hi. Thank you very much for your presentation. My name is Tetsuya Hamada from JPIX. It is really nice to hear your presentation. Being first time, not in Japan, but at this global place held by in Bangkok. And I have one question. So you said APN is like a highway And if we connect current DC and DC, we get to use a local portion as a current network. So it seems like up limit these local portions bandwidth or quality will be up limit the end-to-end latency. So is there any way or possibility to manage end-to-end latency by these technologies or this kind of thoughts? This is my question.
Of course, so you mean that the application has some limit on the latency, and with some distance, we cannot achieve such application latency request. Is that the point of your question?
My question is, this would be a combination of, a local portion and a PAN. That would be like a highway. It would be a core.
Yes. Yes.
So in case we are thinking about, end-to-end latency, is the, current local portion would affect too much on the quality or not?
I think that's a good question. So in ION Global Forum, we are discussing beyond APNT networking. So how to reduce the network latency in the LAN segment and how to make the quality in the LAN segment stable. So basic idea is, for example, in data center, we are discussing how we make use of optical circuit switches in the data center. So today we have fiber cross connect, but now, like Google, now people have started considering the use of optical circuit switch, dynamic optical circuit switch. So if we combine such an optical circuit switch to local area networks, we can create optical paths for application that requires short latency. So, and in the campus side, we assume that it's just a small segment, so people can just create a fiber path between the NIC and the router. So it's a good question. So we need some work to extend the APN high bandwidth, low latency feature to NIC. And now it's being worked at ION Global Forum. And the key concept would be the integration of packet switch and optical circuit switch. Did I answer your question?
Yeah, thank you very much. And again, thank you very much for your great presentation.
Thank you very much. Any other questions?
Thank you very much. I would like to ask you about the maximum distance from eye to eye. That I saw your presentation POC with about 96 kilometers, I think. What if we need a further distance? What is the maximum distance we can get from eye to eye?
For eye to eye, basically, if we were to connect eyes without any amplifier, the current assumption is about 100 kilometers. But for computing use case, main computing use case is connecting data centers or user sites within one big metropolitan area. So 100 kilometers is long enough. And for some countries like the US, we would like to create more big area with ion APN. In such cases, probably we would have to use amplifier.
Thank you very much.
Thank you. Any other questions? No? I'm sure that if you have questions during the break and lunchtime, our speaker, Dr. Masahisa, would be very happy to speak with you. So thank you very much, Dr. Masahisa, once again. And I would now like to invite Dr. Kotom Arya, Chairman of the THNIC Foundation, to present a token of appreciation to Dr. Masahisa, please. Thank you very much. And now let's take a break for 30 minutes and reconvene again at 11:55 a.m. for our next session on connectivity. Coffee and snacks will be served in the foyer, so just outside the room. It will be hosted and provided by both the hotel and sponsored by Flex Optics, our coffee cart sponsor. We are also proud to announce that today we have the 2023 Barista Champion with us, Kun Jane, who will be making us some coffee today. If you're a coffee lover like me, please be sure to go have a little tasting session. Kun Jane also runs her own coffee shop, Fika & Co., and would be delighted to make you some coffee today. Don't forget to visit our Bang Fan booth that's spelled in Thai or the English spelling. English spelling is bangfun.in.th, BAENGPUN.in.th. Their booth is in the foyer next to the .th booth, and be sure to visit our sponsors' booths as well. Bang Fun is an online platform where community members can sell their products and services without any fees. Now, for those who registered to attend our event and selected to join Bang Fun, be sure to visit them and pick up your rewards, which are very special gifts, iconic gifts from our local communities throughout Thailand. And if you did not register, you can go visit them now and register now and also be rewarded too. So enjoy shopping for some goods and services and enjoy your break and see you soon in 30 minutes. Thank you very much, everyone.